Hi, everybody, and welcome to the Artificial Intelligence or AI Lab. This lab is about probably one of the most exciting fields right now, and it's a field that's touching all of our lives, and that's artificial intelligence. And in artificial intelligence, it's basically going to be changing how we live, how we learn, and how we work pretty much for the rest of our lives. So we want you to understand a little bit about how AI or artificial intelligence works, and think about how AI can be used and how you might be able to use it to solve problems. Because in the end, AI is just a tool. We'll talk a little bit about how that tool works, but it's just a tool, and we want you to be most effective at using this tool. So let's get started. Now, you know that all of our Engineering Tomorrow labs are developed by engineers, and Palin and Ariana, you'll get to see a little bit later, are recent engineering graduates and have helped to develop this lab. But I want to also recognize some really great discussions I had with Philip Nelson, who's director of engineering at Google, and has really been involved in a lot of applications of AI for good around the world. So again, he and I had a number of conversations. We're brainstorming ideas of activities that you'll be able to do in this lab, and also how AI is being used. So thanks very much to Philip, and I think as a result of his help, this has become hopefully a very interesting and useful lab, and you'll have some fun with it. Let's first start with some conceptual basics about AI and really some terminology about what is AI and what is it not. It's important to understand. Artificial intelligence, or AI, is basically a very broad topic, and it's the theory and methods to build machines that think and act like humans. As I said before, it's one of the most exciting new tools we have these days, and it's going to impact us forever. It's already impacting us. It's basically helping improve chatbots. It's helping to recommend the next movie or music that you should be listening to. It's helping to identify activity on your webcams, and it's being used a lot in industry and business these days to help improve work and also streamline activities. Now, one of the things that you'll hear a lot of terms that are kind of part of AI, things like machine learning, deep learning, generative AI, large language models, or LLMs. These are all basically parts, and they kind of fall under the AI umbrella. One of the things that I wanted to talk about specifically is you may have heard of deep neural networks. And again, this is just a certain type of machine learning model that we'll talk a little bit more about later. And it's designed and basically designed based on how our brains work. And these deep neural networks have been used for image recognition and natural language processing and recognizing speech and things like that. And they're helping us do a lot of things. So they're helping us summarize lots of text data. It's helping us do calculations and find interesting patterns in data, creating draft text and images and video and audio. And basically, that's all part of kind of what generative AI is. But again, we'll talk a little bit more about some of these different types of models. On that last page, I was really highlighting two keywords here. One is tool. AI is a tool. And then the other is data. And data is used to train these models. So let's talk about tools first. Now, on the left-hand side of the page, you'll see a bunch of different types of tools. Hammers and saws and all that, screwdrivers, lots of different things. Now, I want you to think of AI really just as a tool. And a tool can have a certain purpose, and it can be dangerous, and it can be used in the wrong way. You want to make sure that if you're using these tools that are on the screen here, you're careful that you don't crush your finger or accidentally burn yourself or cut off your hand. I mean, that tools can be dangerous. You have to make sure you understand how to use the tool. On the right-hand side of the page, we have data. We're going to be talking about data a lot. Now, usually when you think of data, you may think of numbers, just a spreadsheet or a series of numbers that you've measured. But data is so much more in the context of AI. Data is images, like the little, cute little kitty cat there. And as you remember from the other lab, that image can be broken down into pixels and then represented as numbers. Data can be sound waves or songs or music or people's voices and words. Data can be video, and data can be books and text and things like that. So data, all that type of data is data, and it can be broken into numbers that can then be consumed and actually used by an AI model or a machine learning model. We'll talk a little bit about how that is done. So let's talk about a little bit of a basic terminology. So there's three basic classifications I want you to kind of understand here. Let's start from the right side of the page. So if you're trying to create a model, a numerical model that predicts some kind of continuous variable. So for example, the catapult, if you want to predict how far the ball will fly, because that's a continuous distance, you need something called a regression model or a regression machine learning model. And that can be used for predicting things like a temperature or life expectancy, or maybe the price of a car or things like that. Now, if instead of predicting a continuous variable, you want to predict or recognize that something falls into a certain category. So for example, a digit, recognize a digit from somebody's writing, or maybe in your photo album, you want to find all the pictures that have your Uncle Bob in it or your Aunt Sally in it. Then you have to take all those pictures and you need a classification model, and then you're going to find the pictures that recognize Uncle Bob in your pictures collection. So that's a classification type of model. The last terminology is generative AI, and that's essentially kind of running a model where you're going to put in a prompt. So you'll put in maybe a description of a picture, or maybe some other type of prompt that you can speak or you can actually write into the model. And then it will kind of run in reverse, and it will create a picture or a video or a sound based on your prompt. This is one of the areas that's very exciting these days. That's what really makes AI really feel like AI, artificial intelligence. It actually feels like it's understanding things. But it's important to understand that these models are all really based, they have a statistical component to them. These models don't have, morals. They don't have what human beings have. So you have to understand the limitations. And generative AI is, again, one of the most exciting and useful, very useful top things these days, models these days. And you'll get a chance to play with some of that soon. How do you know which type of model or that you want to use, that you should use? So basically, if you want to create something new, create a new picture, create new music, then what you need to do is use generative AI, because you're going to prompt it and the model will generate some output. Now, if you want to categorize data, like I was saying, your photographs, and you want to find a certain picture of a certain person, if you want to categorize that data, then you need to use a classification machine learning model. Now, if you want to predict a continuous value, then you want to use a regression machine learning model. So it's important to understand kind of how these different types of models are used and which ones are most appropriate. Now, let's talk a little bit about these deep neural network models, which is what's shown in the middle of this page here. You'll see that you got all these circles with lines attached, connecting them. So what this is kind of a representation of a neural network. And each of those circles represents a neuron or a node with certain parameters that are associated with it. And these parameters have to be tuned. This model of this type of machine learning model is based on your brain and how our brains work. Because our brains have lots and lots of neurons in it. And these neurons are connected, electrically connected, and they get trained. And that allows you to learn things and actually learn how to speak, learn how to recognize things, and then learn how to have more advanced skills. The way these neural networks are actually trained is you have a training set of data, which is shown on the left side of the page. And that training set of data could be things like numbers, but it could also be text, it could be pictures, it could be videos, it could be code, actual computer code. And that data then is broken down by a process called tokenization into little pieces, basically into numbers or numerical elements, and so that it can be input into the deep neural network model. So then that is actually training the model, and all those parameters inside the model are then being modified to try to get better and better, and it's being trained in comparison to another set of data called testing data, and it basically continues to train so that the output looks more and more like the actual testing data. We're not trying to show you how to do this training. This is quite complex, but it's an exciting field, and it's something that if you get into more computer science, you would understand and learn how to do these types of models. But we're talking about training models that have billions and even trillions of parameters. So on the right side of the page, you can see some of the recent models that gives you a sense of how many parameters were being trained in these models. Now, these might not be actual values because these are kind of secret. The people who are designing these models are keeping close to their themselves the number of parameters. But these are massive models. Now, you may think these models that I've listed here are kind of old hat because we've moved on a lot, and that's one of the challenges of this field, is that it's evolving so rapidly that this presentation is already out of date. But the basic concepts should still be there. Essentially, what we talked about is that we use lots and lots of data for training foundation models. And these models are basically kind of the big models. And then what you do is you fine tune them by adding specific data or specific information so that they're more useful for you. And I had mentioned the word prompts. So prompting is very critical in using these models. You have to, as you vary your prompt, as you change how you word your prompt, that's going to impact what the output looks like. So getting good at prompting these models is a very useful thing to think about, and you'll get a chance to practice some of that in the exercises that we've developed here. So I kind of like to think about these foundation models in this way. Now, this is not a perfect analogy, but it's kind of an analogy. When you were little, when you were born, you were a little tiny baby, and you were learning things. Your brain was starting to get trained. You were learning how to interact with other people and other children in play groups, and how to be nice to pets, and you're learning how to speak and how to recognize people and objects, and then eventually you start to learn the alphabet and how words are made and numbers, and that's kind of like a foundation model. So you are a foundation model, and then as you get into school and you start to do more and more in school, now you're starting to get fine-tuned. So right now you're going through a fine-tuning process. So you know how to speak, how to do math, and how to recognize things. But now we're showing you, and we're fine-tuning you and teaching you how to use AI, and maybe how to actually create more things using the models. That we have to be a little bit careful and understand that they're just tools. And we have to learn how to use them and recognize if some of these models might be have been trained and have biases in their outputs. We have to make sure that we're careful, that we recognize and try to keep bad people, bad actors, from using the tools to hurt people, maybe to scam them and things like that. And also recognize what you read out there, what news that you read, and what information you get. Recognize how much of it is real news and what is fake news. And you have to recognize finally that there is this statistical component to these models, and they can't actually think or reason on their own. So you have to also take what they say and evaluate in your own mind how much you're going to understand and believe about these things. So these are tools. They don't have any moral underpinnings, and we have to make sure we use these tools responsibly and always question the output. But they are very powerful and they can be used for a lot of great things. One of the things that's an issue or that's happening because of the explosive growth of the use of AI is that these models, the infrastructure needed to run them has to grow very quickly. So these models are typically running in the cloud, and the cloud is essentially running in what's called data centers. So these are big facilities with lots and lots of computers, something that you can see on the left-hand picture there. And these data centers are constantly running. That's when you do something in the cloud, that's where the calculations and that's where the processing is done. And these data centers need a lot of power, and they also need a lot of cooling because they generate a lot of heat, the semiconductors. So the power consumption is huge. So there's a prediction that the electrical demand in this country and in the world is going to be going up, and it is going up rapidly because of AI. And in order to accommodate that, we need more engineers who can help design more efficient chips, who can design more efficient semiconductors, who can basically build more power consumption and build these manufacturing in these facilities. And also we need more electric grid capacity. Basically, we need a lot of engineers to help solve the problem so we can continue to advance AI and get the benefits of it. So although there are great things with AI, we have to manage also the consequential impacts of it. So let's talk about a couple of the applications of AI. Here's one that is quite interesting. Basically, Google and NOAA, the National Oceanic and Atmospheric Administration, teamed up to analyze a lot of sound recordings from whales. And they used basically the machine learning models to understand these sound waves and also basically to analyze this data and they got a whole new understanding of whale migration patterns and different types of whales and things like that. So this was very helpful for the protection and conservation of the marine ecosystems, and it's really a great tool for managing huge data sets. This is again machine learning or AI type of model. Now another similar application is on land. So there's a model called a mega detector, which allows biologists around the world who are looking at trap data. So basically cameras in the woods and in the wild. That take pictures, photographs of wild animals, and they're able to process huge amounts of data and identify animals. And again, it's another great application of using AI to help with wildlife research and conservation projects around the world. And this is being used all over the globe. Here's another example of using AI, again, image analysis. So this is to help identify a condition called diabetic retinopathy, which is a cause of blindness for people with diabetes, where you want to try to detect this early. And again, here is a case where a model has been trained on retina scans, and it can be a tool that can be used by doctors or healthcare workers around the world to identify where there's a risk. And again, this is a great tool that can be used in parts of the world where there may not be enough healthcare workers who have the skills to read these images. And again, it's an application where AI can be used to really help humans and human populations. So let's talk about the elephant in the classroom here. I'm sure you've been thinking that AI would be a great tool for you to do your homework. Now, again, it's a tool, and I think what's going to happen in the education system is that we have to learn how to live with this tool, and learning how to learn. You're learning how to integrate it into the learning process is going to be something that will take time. But just remember, if you just ask AI to do your homework, then you're not actually fine-tuning your brain and you're not improving your skill set. So we want you to continue to learn, continue to increase your skills. But what we need to do is figure out how can AI work to help you do that, because AI is out there. It's not going away, and you want to make sure you don't turn your brain over to AI, and you don't become fine-tuned to be a very productive member of society. If you want to learn a little bit more about the details of generative AI, machine learning, and these various things, there's a great video here, which is a little over 8 minutes long, that can help you understand some of these differences.
Hi, and welcome to Introduction to Generative AI. Don't know what that is? Then you're in the perfect place. I'm Roger Martinez, and I am a Developer Relations Engineer at Google Cloud, and it's my job to help developers learn to use Google Cloud. In this course, I'll teach you 4 things: how to define generative AI, explain how generative AI works, describe generative AI model types, describe generative AI applications. But let's not get swept away with all of that yet. Let's start by defining what generative AI is first. Generative AI has become a buzzword, but what is it? Generative AI is a type of artificial intelligence technology that can produce various types of content, including text, imagery, audio, and synthetic data. But what is artificial intelligence? Since we are going to explore generative artificial intelligence, let's provide a bit of context. 2 very common questions asked are, what is artificial intelligence, and what is the difference between AI and machine learning? Let's get into it. So one way to think about it is that AI is a discipline, like how physics is a discipline of science. AI is a branch of computer science that deals with the creation of intelligent agents and are systems that can reason, learn, and act autonomously. Are you with me so far? Essentially, AI has to do with the theory and methods to build machines that think and act like humans. Pretty simple, right? Now let's talk about machine learning. Machine learning is a subfield of AI. It is a program or system that trains a model from input data. The trained model can make useful predictions from new, never-before-seen data drawn from the same one used to train the model. This means that machine learning gives the computer the ability to learn without explicit programming. So what do these machine learning models look like? 2 of the most common classes of machine learning models are unsupervised and supervised ML models. The key difference between the 2 is that with supervised models, we have labels. Labeled data is data that comes with a tag, like a name, a type, or a number. Unlabeled data is data that comes with no tag. So what can you do with supervised and unsupervised models? This graph is an example of the sort of problem a supervised model might try to solve. For example, let's say you're the owner of a restaurant. What type of food do they serve? Let's say pizza or dumplings. No, let's say pizza. I like pizza. Anyway, you have historical data of the bill amount and how much different people tipped based on the order type, pickup or delivery. In supervised learning, the model learns from past examples to predict future values. Here, the model uses the total bill amount data to predict the future tip amount, based on whether an order was picked up or delivered. Also, people, tip your delivery drivers. They work really hard. This is an example of the sort of problem that an unsupervised model might try to solve. Here, you want to look at tenure and income, and then group or cluster employees to see whether someone is on the fast track. Nice work, Blue Shirt. Unsupervised problems are all about discovery, about looking at the raw data and seeing if it naturally falls into groups. This is a good start, but let's go a little deeper to show this difference graphically, because understanding these concepts is the foundation for your understanding of generative AI. In supervised learning, testing data values, X, are input into the model. The model outputs a prediction and compares it to the training data used to train the model. If the predicted test data values and actual training data values are far apart, that is called error. The model tries to reduce this error until the predicted and actual values are closer together. This is a classic optimization problem. So let's check in. So far, we've explored differences between artificial intelligence and machine learning, and supervised and unsupervised learning. That's a good start. But what's next? Let's briefly explore where deep learning fits as a subset of machine learning methods. And then I promise we'll start talking about Gen AI. While machine learning is a broad field that encompasses many different techniques, deep learning is a type of machine learning that uses artificial neural networks, allowing them to process more complex patterns than machine learning. Artificial neural networks are inspired by the human brain. Pretty cool, huh? Like your brain, they are made up of many interconnected nodes, or neurons, that can learn to perform tasks by processing data and making predictions. Deep learning models typically have many layers of neurons, which allows them to learn more complex patterns than traditional machine learning models. Neural networks can use both labeled and unlabeled data. This is called semi-supervised learning. In semi-supervised learning, a neural network is trained on a small amount of labeled data and a large amount of unlabeled data. The labeled data helps the neural network to learn the basic concepts of the tasks, while the unlabeled data helps the neural network to generalize to new examples. Now we finally get to where generative AI fits into this AI discipline. Gen AI is a subset of deep learning, which means it uses artificial neural networks, can process both labeled and unlabeled data using supervised, unsupervised, and semi-supervised methods. Large language models are also a subset of deep learning. See, I told you I'd bring it all back to Gen AI. Good job, me. Deep learning models, or machine learning models in general, can be divided into two types: generative and discriminative. A discriminative model is a type of model that is used to classify or predict labels for data points. Discriminative models are typically trained on a data set of labeled data points, and they learn the relationship between the features of the data points and the labels. Once a discriminative model is trained, it can be used to predict the label for new data points. A generative model generates new data instances based on a learned probability distribution of existing data. Generative models generate new content. Take this example. Here, the discriminative model learns the conditional probability distribution, or the probability of y, our output, given x, our input, that this is a dog, and classifies it as a dog, and not a cat, which is great because I'm allergic to cats. The generative model learns the joint probability distribution, or the probability of x and y, p of x, y, and predicts the conditional probability that this is a dog, and can then generate a picture of a dog. Good boy. I'm going to name him Fred. To summarize, generative models can generate new data instances, and discriminative models discriminate between different kinds of data instances. One more quick example. The top image shows a traditional machine learning model which attempts to learn the relationship between the data and the label, or what you want to predict. The bottom image shows a generative AI model which attempts to learn patterns on content so that it can generate new content. So, what if someone challenges you to a game of, is it Gen AI or not? I've got your back. This illustration shows a good way to distinguish between what is Gen AI and what is not. It is not Gen AI when the output, or Y, or label, is a number or a class. For example, spam or not spam, or a probability. It is Gen AI when the output is natural language, like speech or text, audio, or an image like Fred from before, for example.
So now we've gone through kind of the basics of AI and in the background, and we talked about some of the terminology, generative AI, regression models, all different types of machine learning, classification models. You've learned a little bit about how they're all related, and you've had some examples of where AI is being used for good and helping people around the world manage data and improve activities and maybe make their jobs better. So now what we're going to do is get you into some of the activities that we've designed. Some activities that hopefully will spur your creativity, teach you something about how AI can be used, and in the end, we want you to think about how can you use AI to solve a problem. So let me hand it over to Ariana, who's going to now take you through 4 activities that I hope you'll have some fun with.
Hi, everyone, and welcome to Engineering Tomorrow's Artificial Intelligence or AI Lab. My name is Ariana Montero, and I'm a recent college graduate from the University of Texas at Austin. Now it's time for you to use AI in our virtual activities. So we have 4 activities for you today. The first is a generative photo activity where you're going to be able to interact with AI, and you're really going to learn about how to write a clear and concise prompt to AI. The second, you're going to conduct a historic person interview. So maybe in your history classes, you're reading a textbook about a certain historical person, but maybe you're not very engaged in this type of learning style. And so here you're going to be able to talk to AI as if it's a historical person and learn about their life. Third is a personal chat box where you can personalize the traits, like the personality traits or how the AI model talks to you. You can also give it a lot of different knowledge so that you can reference that. For example, if you take notes, you're going to be able to reference it if you put it into the chat box. And then lastly, we're going to help you generate code to play a game that you can play with your classmates with the help of AI. And so we'll go over these really briefly. But in your student workbook, you're going to have a lot of instructions on how to complete these activities. And there's also going to be videos that walk you through tutorials on how to complete each of these activities if you have questions. But the first is to use Gemini or ChatGPT to create a silly image of a prompt. And so my prompt was generate an image with a cartoon penguin sliding down an igloo house. You'll wait and see what ChatGPT generates for you. Then you can ask it to edit a certain feature of your picture or ask it to generate something else. In activity 2, you'll see on the right, we have Abraham Lincoln. And so I'm conducting an interview with Abraham Lincoln. In order to do that, in the prompt, I'll type in, engage with me as a character Abraham Lincoln. Then I can ask the AI model to explain different things about his life so that I can learn in a different way. In activity 3, you can fine-tune your chat box, and here we'll be using Google Gemini. You can create your own personal Gemini. Here we showed you an example on the screen of what it should look like. You can give it different knowledge and different personality traits and follow our tutorial video on how to customize that yourself. And then lastly is learning how to code with AI. So just to give a bit of background, Python is the most commonly used programming language, and you use it a lot if you're interested in machine learning and AI. And so we have resources at Engineering Tomorrow. We have a free scientific computing course that you can register for and learn about Python. There's also free online classes where you can learn about Python. But today we're going to be using Google Colab to learn about how to code. And Google Colab is really cool because it has Google Gemini, which is an AI tool, really incorporated into it. And so Google Colab is a cloud-based Python programming language, and we're going to be using this to generate code that creates an interactive game. And so an example that we've given you today is write a simple hangman game in Python for Google Colab. Let the user guess letters, show which ones are correct, limit them to 6 wrong guesses. After you're done with this and you've iterated on your code, maybe you've tweaked it a little bit or asked Google Gemini to help improve your code, then you're going to ask Google Gemini to write comments throughout your code, and that's how you'll learn how to code and how Google Gemini formatted the code to create your game.
So these are all hopefully fun problems that you can work with. And your student notebooks will have more detail about how to walk through all this. But now that after you've finished all these little exercises, You should have a sense of how AI can be used. And now what we wanted to do is have you think about what kind of problems can you solve with using AI. And if you'd like to do more of this, if you have the ability to use AI in a creative way, you're going to be very useful for future employers. So can you just some ideas? Can you think of how you might develop a tool for helping an older person remember some important tasks during the day? Can you think of tools for helping to make learning math or English more fun? So maybe the exercise you did with interviewing a historical character could be an interesting way to learn more about history. Can you think of tools for helping people get enough food to eat? I mean, maybe there are machine learning models that can help aggregate information about food centers and how you get that information to people. So again, there's no limit to the number of problems we can work on, and AI again as a tool can be a great way to help solve some of these problems. If you enjoyed these activities, and you enjoyed this lab, there is a lot of opportunity in the future that you could get involved in this industry. So basically, computer algorithms, machine learning. There's a lot of. This is a very short list. There's all kinds of engineering is going to be using AI. But if you really like the coding part or the nitty-gritty of these models, you might want to do computer science, data science, computer engineering. But I suspect that every field of engineering that you go into, whether it's chemical, mechanical, electrical, environmental engineering, anything, these applications, these engineerings are going to be using AI and these AI tools. So it's an exciting future, and we look forward to you as the next generation of workers to be a part of that and to use these tools. So I hope you enjoyed the lab, and thanks very much. We hope you think about how AI works in your life going forward. So thanks a lot.